Hello, everybody, and welcome to the Cosmos Show, the place to be if you're curious about the universe. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from a space doctor, learn about life from the eyes of astronomers, and find out what's going on above your head all in the same place. Join us every other Tuesday, 6 p.m. Mountain Time on YouTube, Twitch, and now Facebook. You can chat your questions on either Twitch and Facebook. You can also call in and ask your questions live using the login information on the screen. You'll just connect through our Zoom show, and we'll see you then. This week, we're going to chat with Ellen Thompson, a graduate student and science educator at the University of California, Berkeley. Ellen uses spectral modeling to predict other characteristics of stars. And tonight she'll tell us all about how she plans to use that as an educational tool. But before she joins us, let's welcome our co-stars. First, PhD candidate in astrophysics from the University of Chicago and the host of her own YouTube show, Nora's Guide to the Galaxy, it's Nora Bailey.
Hey, y'all.
Hey, Nora. Next, medical doctor and founder of Orbital Biodesign, it's Dr. Danny Carroll.
Hi, everybody.
Hey, Danny. Next, Director of Education and Public Outreach at the Vera Rubin Observatory, it's Dr. Lauren Corlies.
Hello.
Hey, Lauren. And last, but certainly not least, postdoctoral scholar from the Simons Observatory, it's Dr. Nick Galitsky.
Hi, everybody.
Hello, Nick. All right, everybody. Thanks for being here. We've got a fun show today. We're going to do things a little bit different once we get down to Astro 365. We're going to do some current events trivia. But before we do that, let's go to Astro advice. So today, our quotation comes from Ronald McNair, who says, whether or not you reach your goals in life depends entirely on how well you prepare for them and how badly you want them. So I would love to hear what everybody has to say about that. And then at some point, I'd like to just say a little bit more about astronaut McNair, because he was an absolutely incredible individual. But yeah, if anybody has any thoughts on the quote, that would be great to hear.
I think he's spot on.
Oh,
go ahead.
Yeah, I think Ron McNair is really awesome, but I don't totally agree with this quote, actually. And I think it hinges a lot. I think the word entirely is doing a lot here. I really wish that it was the case that, you know, achieving your goals depended entirely just on that. But I think that ignores a lot of other factors that are at play, like luck, privilege, and like setting good goals in the first place. Like, I think, you know, you can want something badly your whole life, and if it's not a realistic thing, then it's not going to happen. But I do think that these are very important things, and if you do set achievable goals, then you should prepare yourself for them and really, really want them and achieve them. But I don't think it's entirely going to be up to that.
What were you going to say, Danny?
I think he's right with the, I guess, with the exception of what you said, Nora. And then there's a timing component as well that can be a little bit tricky, but I think sometimes persistence can overcome the timing piece, at least to some extent. So.
Yeah, as Nora mentioned, the entirely is what kind of got me on this quotation as well. And you may be aware that there's some tragic irony in this, because astronaut McNair was killed in the Challenger disaster. And so there is this, rather gruesome part of chance that we just can't plan for. The random events that happen throughout history that change things in ways that we can't plan for and can't possibly foresee. One of the unfortunate things that he was never able to do was what he was planning on doing the next day on the ISS, among other things that he was actually training to do. One of the side things that he wanted to do was to get the very first recording of an original piece of music recorded on the ISS. He was a saxophone player, and he had written a piece of music specifically to be recorded on the ISS the next day. So one of those unfortunate things that never happened. But yeah, he, like I mentioned earlier, he was an extraordinary individual. Not only did he have a PhD from MIT, he had several honorary doctorate degrees, as well as a 6th-degree black belt in karate and several national and regional championships. He was a brilliant physicist. I think he studied laser technology, actually, for his first job at the Hughes Laboratory in California. And another really interesting thing that I found out about him when I was researching him today was that he was the first member of the Baha'i religion to ever go into space. And I had never heard of this religion before, but I looked it up, and really, really fascinating, relatively new faith just from the last couple hundred years, in which all religions are honored as being equally valid, and truth being found in all of them. I didn't know anything like that existed, but he was a follower of that faith. So yeah, really, really extraordinary guy. And I certainly feel, as Nora and Danny already pointed out, that he's right on. It's just he left out chance. Nick?
I was just gonna say that, yeah. From his perspective, maybe that does hold true. But if you ever want a humbling experience, you just look at an astronaut's resume. I never understand how how did you do all that? But yeah, very impressive.
I mean, for example, I would love to be an astronaut, and I was actually too tall to be an astronaut, and there's literally nothing I can do about that. So I can want it and prepare for it as much as I want, but unless I start shrinking.
Well, these days you just got to make enough money. I mean, have you just chosen a career?
That's true.
Or you had
That's true. They've actually taken the strict height requirement out of the NASA requirements because it was based on the spacesuits, and now they're more adaptable. So technically, I might not be too tall anymore, but probably I still am.
There you go. I guess, Danny, any comment? You making taller suits yet?
Well, so there's going to be a lot of variety moving forward because there are a bunch of different spacecraft that will be flying people on. So, it's not just the anthropometric measurements don't just pertain to the spacesuits, but also to crew capsules and whatnot. And especially now that we're not going to be restricted to Soyuz for launch and landing anymore, the options are pretty endless. So.
I love the idea that our space capsules are going the same way as our cars.
Interesting, isn't it?
Yep. Someday people will be just as annoyed about traffic in space as they are here.
I also wanted to mention off your comment, Nick, beyond just astronaut resumes, also the people who apply to be astronauts, their resumes are equally humbling. One of the statistics from astronaut McNair's class, he was, I think, one of 20 out of 35,000 applicants that year. So it gives you an idea of just how many incredibly qualified people are applying to be astronauts and how few are actually selected. But
Some more qualified than other. I think I've applied twice now, but I kind of knew that wasn't going to happen.
Well, I haven't even gone that far. Any other thoughts on this piece of advice? All right. Well, like I mentioned, we're going to try something a little bit different today for Astro 365. Oh, actually, before we do that, though, I did want to mention one more thing about astronaut McNair that I just remembered when I saw his picture up there. So when he was 9 years old, he walked into a library that had already been segregated. This was in 1959. And for whatever reason, they wouldn't let him check out his books. And he refused to leave. And so after the police were called and his mom was called, he was allowed to check out his books and he left. So, I mean, I just think that is an absolutely amazing story for anyone, let alone a 9-year-old. And I think that was a testament to the type of person that he was, and fits with this quotation really, really well. And he was the second Black person in space. He did actually fly on one previous mission on Challenger, went up to the ISS before the 86 disaster. And then, like the other astronauts in that shuttle, as well as all the ones on Columbia, they were all awarded the Congressional Medal of Honor, I think in 2004. But last thing, that was what I wanted to say about astronaut McNair. So now down to Astro 365. In the year 1806, there were two large masses streaking through the sky that sent shock waves off across the French countryside. And then two large fragments landed in two small towns, one weighing approximately 4 kilograms, another weighing 2 kilograms, shattered upon impact. And then all the country folk went to investigate and picked up all the little pieces that they could find. There were a couple scientists apparently living nearby who were alerted to what was happening. They went out there, collected as much as they could. But over the years, people lost track of all the little fragments, and now less than just a few ounces remain of the original 6 kilograms of this meteorite that streaked through the sky. And apparently it was the first carbonaceous chondrite to be identified. And even then it was still suspect whether it actually had other than earthly origination, but was later confirmed to be in fact a meteorite. But yeah, interestingly enough, it's mostly been lost. And the pieces are all in private collections around the world, and just some small fragments remain. But we, I think it was maybe 2 shows ago, we saw that video of the big meteorite that came through Russian skies several years ago. That one was even bigger. That one was several kilograms when it actually landed. Were you gonna say something, Nick?
Yeah, is this the type that's the bunch of like rocks glued together sort of type? I don't know my meteorites very well.
Yes, it is that kind. Yeah, that look kind of like a conglomerate rock. Yep.
Right, as opposed to like the iron nickel cores or something.
Yeah, they've got a different name, which I'm totally blanking on right now.
There we go. That was your first question. Oh.
I think I got it half right. All right, so here's how this is going to go. I have 5 questions for each of you, and Lauren, I'm glad you made it. Now we can do your questions as well. And so this is going to be rapid fire. So if you don't have the right answer in a few seconds, I'm going to give you a little hint, but hopefully you get them in one here. But This is some of the most recent stuff that's been coming through the pipes on science events. So we're going to start with Danny. All right, Danny, you ready for this?
I don't know, am I?
I think you are. You got this. It's in the bag. All right, here we go. Question number 1. The Mega Moon rocket is NASA's new launch vehicle for their upcoming mission to the moon, named after this Greek goddess.
You mean Artemis?
Artemis, you got it. Nice. Excellent. This week, 2 astronauts will be doing spacewalks on the ISS to begin installing these important upgrades.
Is that for me?
Yeah.
Oh, I'm sorry. Would you repeat the question, please?
Yeah.
I thought we were going sequentially.
No, I'm going to give you all 5. Number 2.
Wow.
You're good. Yeah, we're gonna keep you on your toes here.
Yeah.
So this week, 2 astronauts will be doing spacewalks on the ISS to begin installing these important upgrades.
Oh, I don't know, but it's Kayla Barron and Raja Chari, I believe, who are
Hey,
doing.
I think that's pretty impressive that you knew the astronaut's name. So we're going to give this one to you. It was solar panels.
Oh, right.
I feel like that's like even like
Always.
a bonus point for Danny.
It's always solar panels. No.
Yeah, so, yeah, new upgrades on solar panels. All right, number 3. This country just announced that its space station will begin welcoming commercial activities.
China?
Nicely done, Dr. Danny. This branch of the US Department of Defense was allocated even more money than what the Biden administration requested.
Space Command or Space Force?
Yeah, Space Force, very nice. And last but not least, launched this morning, this company's new partnership with Spaceflight Inc. offers opportunities for private companies to get their satellites into orbit.
Oh, I'm not sure that I know.
Think of the movie a couple years ago with Brad Pitt, kind of a dark space movie.
At Astra?
Astra, that is the name of the company. Nicely done, Dr. Danny. I think you got even like better than a perfect score with knowing the names of those 2 astronauts. So excellent job on your first round of trivia.
Thank you.
I'm impressed. All right. We are going to Lauren now.
Oh no, I have to follow Danny.
Now you're good. And hopefully we got those pictures back up there on the slideshow. We had taken them down when we didn't know you were going to make it, so hopefully they're there. But if not, that's okay. Okay, here we go. Earlier this month, students from this state had an opportunity to speak with astronauts live on the ISS.
Oh. I don't think that I know. That's cool though. I wish it was Hawaii.
And I'll give you a hint. It's in the Midwest, one of the big states there. Swing state.
I mean, now I'm gonna feel self-conscious. Like, am I guessing correct or Midwest?
I could.
From the East Coast. Sometimes
another.
I get
It contains a salutation when you say hello to someone. You could say hi, and if you put the letter O on either side of that, you get
Ohio.
Ohio. Nicely done.
I got there.
They're the 3 astronauts that they talked to. All right. Excellent job. More than a dozen satellite missions need new rides to space because of the invasion of this country.
The invasion of Ukraine by Russia.
Ukraine. Yep.
Yeah.
Yeah, Ukraine. Despite being invaded by Russia, this month, Ukraine gained access to this company's internet service.
Not certain. I didn't hear that one.
Think satellites.
Starlink comes to mind. Are they offering the internet already?
Yeah, and the
Yeah.
company behind Starlink is
SpaceX.
SpaceX. There you go. Okay, excellent. 3 out of 5 so far. The Hubble Space Telescope got lucky and just happened to find these 2 objects at the perfect angle to reveal exquisite details in both of them. And we're looking for the category of objects here. It's right up your alley.
Guessing galaxies.
2 merging galaxies.
Hooray.
Okay, last but not least, researchers at the National Ignition Facility at Lawrence Livermore National Laboratory in California used 196 of these to understand the conditions inside galaxy clusters.
Like computer clusters, maybe?
You're on the right track. We actually talked about this before when I was talking about astronaut McNair. It's what he studied as a physicist.
Oh, lasers.
Lasers, 196 very powerful lasers,
Oh,
all
cool.
concentrated into a tiny, tiny little area. All right, excellent job, Lauren. All right, we are going on to Nora.
All right.
All right, ready for this? Okay.
Ready as I'll ever be.
All right, NASA and HeroX announced a data analysis contest for the public to find ways to autonomously analyze data in order to find out if life once existed on this planet.
Mars?
Yeah, there you go. Okay, later this month, this SNL comedian and actor will get a free ride on Jeff Bezos' Blue Origins.
That's Pete Davidson.
Pete Davidson, lucky man.
In many ways.
Yeah. NASA will participate in the 2022 Commodity Classic to share resources with this important industry. This is a tough one. Yeah.
The
This is tougher.
2022 Commodity Classic.
Yeah. Yeah. Who are they led by? What important industry?
Like the oil and gas industry.
I would make sense. I would go with that as well. Think where you get your food from.
Grocery stores.
You're on the right track. It is agriculture.
Oh,
These
okay.
are
I'm
all
from Iowa. You'd think I would think of that.
these are yeah. This is the Commodity Classic is led by farmers, and apparently NASA satellite images of farm productivity
That makes sense.
provide tools and resources that are going to be helpful for that industry.
Very cool.
Okay, next one. On Monday, this flew past the Earth at about 200,000 miles away.
An asteroid?
It was an asteroid. In fact,
The one
it-
that was half the size of a giraffe.
yes, that's the one.
Which is my favorite size comparison.
Yeah. All right, and last for Nora. This week, NASA is excited to share updates on the final alignment of all 18 mirrors of this giant telescope.
I don't know. Maybe the James Webb Space Telescope.
Yeah, that was a tough one, right? Okay, good job, Nora.
Okay, 80%, that's passing.
That's pretty good. 4 to 5 ain't bad. If you're a baseball player, that'd be the best batting average of all time. All right, Nick, here you go. Ready?
Sure, why not?
And I must say, I think yours are the hardest, but
Oh boy.
you got this. You got this. Okay, here we go. Earlier this month, the ESA released an image taken using the Hubble Space Telescope showing these emanating from a star in the Orion Nebula.
Oh, it's always jets. Why not jets?
You got it. It is always jets. In this case, incandescent jets of gas traveling at supersonic speeds. Yep, nicely done. Okay, number 2. Another recently released photo taken by a telescope on board the ISS imaged merging hotspots on this intense type of star.
Merging hotspots. Oh, we can just start going down the types. Let's say a red giant. Like a red giant.
Not a red giant.
Cepheid variable.
Nope. Even more intense than that. Way more intense.
Way more intense. White dwarf.
Nope. Even more.
We're gonna run out of star types here.
So here, I'll give you a hint. So the intensity has to do with its magnetic field.
Oh, is this a pulsar or magnetar?
Magnetar, you got it. Nicely done. There you go.
Ooh.
All right,
Cool.
isn't that cool? Yeah, they gave us a nice little GIF image as well. Okay, here we go. Earlier this month, NASA launched the third of a series of next generation satellites to monitor this.
Third of a satellite to monitor. All right. Is it something on Earth?
It is something on Earth.
Okay. Because that's totally outside of my field.
Yeah, I know. This is kind of a red herring for you, Nick. It's actually. Go ahead.
Oh, I guess an ice.
You're on the right track. It does have to do with ice.
Snow coverage?
Maybe.
No. Ice
Yeah,
coverage?
you're on the right.
Yes.
You're on the right track there. Think broader. What would be all encompassing with like ice and rain and snow?
Were you looking at sea level, ice caps?
You're on the right track. Even broader, maybe above the Earth as well as on it.
Ooh, cloud cover?
So close. We're gonna give it to you. Earth's weather.
Oh, just generally weather.
Okay, here's an easy one for you. Here's an easy one. Here you go. Now we're getting back to you. This helicopter just completed its 21st flight on Mars.
Oh gosh. I mean, I know the little guy. I want to say it's like integrity or innovation. Or
Yeah, you're so close. You're so close. You're killing Nora though. Think geniuses.
Ingenious.
So close. Ingenuity. Okay, we got one more for you. Here we go. Last one. Last week, researchers using the high energy stereoscopic system, otherwise known as HESS, announced that particles were accelerated to their maximum predicted speeds by this event.
Boy, maximum speed particles is usually like, I don't know. Does this involve black holes?
Well, maybe eventually, but not quite yet.
Ooh. Give me another hint.
It's not super, it's just normal.
A normal collider.
You're so close. Not a super blank, but just a regular.
Super blank. Man.
Think stars here. We're in astronomy. Not a super blank.
So no, supernova, regular nova.
A regular nova. You got it.
You got me there.
A regular nova. In fact, a very specific one, an RS Ophiuchi. Apparently a very enigmatic regular nova, goes off about every 15 or 20 years. All right, that was fun. We are definitely going to do that again. And if y'all have any trouble you want to hit me with, you can do that now that I've just rolled you over there.
Oh, my heart breaks for poor little Ingenuity. which was my pick for the top news story of 2021, actually.
Oh, all right.
Yeah, I love Ingenuity. But actually, Sam, I do have a little bit of trivia for you.
Okay.
I noticed
Let's do it.
that you said the ESA, and I think I wanted to point this out because I think probably a lot of our viewers don't know this either, but actually they usually just go by ESA. So it would be like saying the NASA or something. So just fun fact. I didn't know that myself until like a year ago. So
yeah, European Space Agency. Yeah.
Yep.
That's good. All right. Well, now y'all know what I'm planning on doing for you again in a couple of weeks. So if you want to take some time over the next couple of weeks to come up with some doozies for me, you are welcome to do so. That'll be a lot of fun. But it is time to take a break, and we'll be back in just a minute with our special guest, Ellen Torres Thompson. So go grab a bite to eat, grab something to drink, and come on back in just a couple minutes. We'll see you then. I'm thinking of doing something like a balderdash-ish deal with the quote. Right. So we'll give you four quotes, and we'll put in erroneous names on 3 of them. And you'll have to pick which quote is actually paired up with the correct scientist. We'll keep it all like very famous folks, like names that you know. But I think that'd be a lot of fun. Welcome back, everybody. We are here with Ellen Thompson, a graduate student at the University of California, Berkeley. Ellen, thanks so much for being here.
Yeah, of course. Happy to be here. Actually, I did my undergrad at California, Berkeley, and I'm in Berkeley doing science outreach right now. I'm on a leave of absence from the astronomy PhD at New Mexico State University.
Okay, well, thank you for clarifying. I apologize for that mistake.
No worries.
Well, we'd like to start off these guest spots with the same question for everybody, which is, what's the one question that you wish everybody would ask you, but nobody does?
Well, I know people often ask, who's your favorite musical artist, but I like to listen to music by the album. So I would like to be asked, what's your all-time favorite album?
Oh, and the answer is?
It changes every once in a while, but for a couple years now, it's been Mirror Master by Young the Giant.
Oh, very nice.
Thank you.
Cool. Well, Ellen, tell us a little bit about how you got into astronomy, the path that led you there, and what you're up to these days.
Right, so I've been a space nerd ever since I was a little kid. It was actually, I have the book right here. The Magic Treehouse Research Guide to Space that got me into astronomy when I was in like 1st grade. And so I knew as soon as I started college that I wanted to major in astrophysics. And that is what I did. I actually also doubled in South and Southeast Asian studies, but that's another fun story. And right after undergrad, I started my PhD, but you've all caught me at an interesting point in my professional life, because even though I'm on this leave of absence, I'm really working on transitioning into a career in science education. I think I have found that's where my heart lies.
You're in very good company here, Ellen. So no worries there. Cool. Well, I mean, I personally would love to hear about your East Asian studies. How did that come about? What led you to that? And then tell us a bit more about what you're doing during your leave of absence.
Right. So I'm Tagalog I'm Filipino on my mother's side, and I started taking Tagalog language lessons at Berkeley just to kind of get in touch with my roots. And then I started taking like some Filipino classes, like cultural classes, and the Southeast Asian Studies department is really underfunded. So my professors were like, could you declare the major so we get tenure? And I was like, oh, okay. So that's how that happened. And during this leave of absence, I first was just really burnt out after not taking a break before grad school. So I spent a solid month in January just watching Star Trek on the couch. It was great. And now I'm doing a bunch of tutoring work across a few different subjects. So a lot of STEM. I'm helping some folks out with astronomy, chemistry, biology, but I'm actually also helping a student out with AP English language. So that's really fun. And yeah, that's what I'm up to.
Well, I'm very jealous that you got to spend a month on the couch watching Star Trek. That's kind of like a dream vacation. Was there a specific episode or a specific Star Trek series that you were watching?
I rewatched The Next Generation, which I had watched for the first time in high school. It was really fun to rewatch. And then I started Deep Space Nine, which I'm almost done with now.
That is one of my favorites. I love Deep Space Nine. Recently, though, I've started watching Lower Decks. If there are any Star Trek fans out there, I highly recommend Lower Decks. It is
That's the
fantastic.
animated one.
It's animated, but it is such a good adult cartoon. I sometimes need to pause it because I'm laughing so hard. It is really, really good. I mean, imagine all the folks in Star Trek who take out the trash and who clean, the bathrooms and dorm rooms for everybody. And like, these are the folks who are the stars of Lower Decks. It is amazing. These are all the people who really run the spaceships.
Definitely on my watch list.
Yeah, it's a good one. But Next Gen is awesome as well. It's definitely the Star Trek that I grew up with. Cool. So, so you're working as a tutor, and I know that you had mentioned one of the recent projects that you did with some fellow classmates on stellar classifications using spectral modeling. And I'd love to hear a bit more about that, if you want to share some of that.
For sure. So I do have a spiel here. I have some notes to read off, but
Cool.
if any of this goes over folks' heads, totally okay. I don't really understand half of this. I just think it's kind of neat. So this was a project for the Astronomy Data Lab at UC Berkeley that I took in my last semester at Cal last spring, almost a year ago now. And this was definitely the hardest class I took at Berkeley. It was really painful, but I learned a lot. I had a lot of moments of, wow, this is the first time I've seen XYZ idea, topic, whatever. And in the last few months of thinking about education and the kind of work that I'd like to do with improving K through 12 and college curriculum, I've been thinking, that class would have been less painful if I had seen some of this stuff before. There's a lot of ways that the things that I saw in this project specifically could be integrated earlier in curriculum. So I'll go over the project a bit. It's kind of extensive. It was all based on this paper that I have a screenshot of the title from here, The Canon, a data-driven approach to stellar label determination by Ness et al. I think the folks who worked on this paper put at least a year of work into it. My professors gave us a month to do a project on it that was even more extensive than the paper. And I'm going to try to describe it in 5 minutes. Here we go. So this was my very first exposure to data-driven modeling. Intuitively, when I think about what we can learn from looking at spectra, I think about very, very physical things, very sitting down with our physics laws. I think about, I can compare the observed absorption lines to laboratory emission lines to figure out what the star is made of. I can use Wien's law to determine the surface temperature just given an observed peak wavelength. But building a data-driven model just throws all this physical intuition out the window. I'm very fond of a phrase one of my peers coined during this project, let's just hit the data with the math hammer. So following Ness et al., we started with a selection of apogee spectra of red giant stars and their derived stellar labels for 5 parameters: temperature, surface gravity, the iron-hydrogen fraction, magnesium-iron ratio, and silicon-iron ratio. Our first goal was to predict what spectra should look like given known stellar labels. So backwards of the real life process, if you look at the spectra and you figure stuff out about it, but a useful exercise. This took some linear algebra, which was on the previous slide. I know it was really ugly and we don't want to look at it, but if anyone's interested, I can explain it in more detail later. And when you take this linear algebra, basically that's your math hammer that you hit your data with, and you end up with a pretty decent spectral model. So I have a comparison on the next slide of the true spectrum for a star from the apogee data set overplotted with the spectrum yielded from my model. So the blue is the data and the magenta is my model. And what do you know? They actually overlap pretty nicely. If we go to the next slide, we see a smaller zoomed in wavelength. And okay, you see from this, the model isn't perfect. The data is black, the model is red, and they're not perfectly overlapping. But I think this is really impressive for a data-driven approach, just getting a computer to figure out what are like the mathematical relations between these data points, not knowing anything about physics or astronomy. So I know I've thrown a lot out there to chat about, but briefly, there was even more to explore just for this assignment alone. We did some MCMC modeling. We made spectral animations from simulated data. I have one of them on the next slide, I think. So you can click play, it's just a couple seconds. This is what the spectrum of a star might look like as time passes, as it is ascending the red giant branch. So that was a cool thing I learned how to do. I'd never made an animation in Python before. This project also introduced me to neural networks for the first time, which we delved into later in the class. And I've been thinking a lot about neural networks, specifically those with astronomy applications, how this sort of project could be integrated into more general computer science curriculum. It's pretty dense, confusing stuff at first, but I think putting this stuff in the perspective of astronomy, which is fun and pretty, makes nitty-gritty, ugly computer science a little less painful. Anyways, with all that being said, I'll turn it over to y'all for questions and comments.
That's super cool, Ellen. I definitely appreciate the astronomy context, obviously, and like to say that astronomy is the best like gateway drug to science, right? You can't hook people in astronomy. What do you think you're going to hook them on?
Exactly.
So yeah, I really think that, yeah, using an astronomy context to teach computer science is awesome. No doubt. We just had a presentation a couple weeks ago on network theory, actually. It was really fascinating. So nice dovetail with that as well. Any questions, comments from any of the co-stars?
Yeah, I think this is really cool. And I often joke about, like, I write a ton of code, like half of my life is coding, but I'm an astrophysicist. And so I always say I write very terrible code because I'm not a computer scientist. So I think it's interesting, like, yeah, like you said, like if there's more exposure to it, like going into things, like maybe we could all write better code. But I was curious about the animation you showed of the spectra changing as the stars ascend the red giant branch. I'm just curious why that happens. I guess it looked like it was just the lines getting deeper or something. I'm not totally sure.
Yeah, so I'm a bit rusty on what exactly is happening here too, but so as folks probably know, when a star is ascending the red giant branch, it's evolving after having left the main sequence. It's run out of hydrogen to fuse. And the physical parameter that we're seeing vary with time here is surface gravity, which in the data set was given as the logarithm. So at the very beginning of this animation, surface gravity log G is 3.5, and then it gets lower and lower to 0.5 on the last frame. So intuitively it makes sense that surface gravity is getting lower and lower the longer that you're a red giant, because it's like a balloon getting expanded. And as this happens, like you said, the spectral features across the board of wavelengths sort of elongate. And how we interpret this depends on how we're thinking about metallicity. If we're thinking about stars with the same metallicity, then the very beginning of the animation is a warm star, still not that far off from its main sequence temperature, with relatively high surface gravity, that has a spectrum that looks like a main sequence spectrum. And then as we get towards the end, we're looking more at a much cooler, much lower surface gravity star. But that's comparing stars with the same metallicities. If we're thinking about metallicity changing with time, it gets quite a bit more complicated. I have my notes from the original project here, which I suppose made sense to me at the time. I say that if you had a star more metal rich, then its spectrum would look even more elongated. So the weirder the metallicity, the weirder the spectrum, I believe. Yeah, that's my understanding on that.
Okay, cool. Yeah, no, that's really interesting. So basically the effect we're seeing here is due to the surface gravity change and not necessarily like an actual composition change within the star's atmosphere or something.
Yeah, exactly.
Thanks.
I was wondering if you could talk a little bit more too about like what excites you for this potential in education, because we think about that a lot on my team about how we can use data as a way to get people excited and to get their hands on the data. But also within the context of most teachers in classrooms don't have the types of computer science skills that if you're not teaching computer science, you wouldn't have, or if you're not an astronomer. So how can we help empower people to use data in a way that's really intuitive and easy? But that's a very specific goal. Like, let's focus on the astronomy and the data, but there's a whole other side of like, we could also, teach people coding skills. And so I'm wondering which part of that excites you, both, neither one, I'm not sure.
Right. I'm excited on the astronomy aspect of it. I think it's just really wild that we can figure out so much about stars from looking at this spectrum, and I think that's something that we can gateway people into being interested in, even if they're not astronomy majors. One of my favorite things to teach is astronomy for non-science majors, and from the coding point, I don't know how to code. I come from a low income high school. I'm first generation. I did not know what computer science was coming into Berkeley, and I took an introductory Python course before I took this data lab, but I felt like for most of this course I was bare bonesing it. I was on Stack Overflow all the time looking things up, and it was really frustrating, but my professors did a really good job of scaffolding things out. It wasn't, here's this paper and now make this model to get this comparison of a fake and a real spectra. It started out with, okay, here's how you're going to download the spectra. You're going to go to this website, and the method that we use for downloading these big globs of data is this thing called rsync. And so it was really learning all of these little tiny things. Sometimes I would even forget the astronomy problem that I was working on because I'm sitting here trying to figure out how this rsync thing works. And it's learning how to open a FITS file, which, astronomy folks are like, yeah, I know how to work with a FITS file, but I never saw a FITS file before starting undergraduate research my second year of college. But just looking at this project in retrospect, I'm thinking I think I could teach a 10th, 11th grader how to work with a FITS file, and that could make their life so much easier if they decide to go into this field. If they decide not to, that's fine. It's fun to just learn on its own. In this project, we learn how to normalize the data because it's given to us in all these ugly numbers. And okay, how do we get it to a nice, pretty normalization? We learn how to make corner plots, which I just think look weird, but that was fun to learn. We learn how to identify bad pixels going between different tables in a FITS table. We learn, I'm just scrolling through this massive Jupyter notebook for this project. I learned how to work with Jupyter notebooks in this class. I didn't even know what a Jupyter notebook was. And I learned how to make my plots as pretty as I could. That was fun. You folks might have noticed the spectra combination was by Pride Flag themed. We learned how to print out the amount of time that it was taking for functions to run, because a lot of the things we need to do here, like with the MC fitting, take a long time. You don't just start your block of code and it's instantly done. I need a little progress bar to see, how long of a walk can I go on while I wait for this. It's a lot of fundamental CS steps that I just have so many thoughts on how this stuff could be taught at different levels.
I was gonna say, don't sell yourself short. You just listed off a whole list of things that demonstrates you know how to code, and that you learned it in that class, and that's great, because I think that's something that happens as you keep going on, especially in astronomy, where you're like, well, I have this problem I need to solve, and I don't know really how to do it, so I still go to Stack Overflow, and like that's part of the process. It's just like, how do you explore what's out there? What can I pull in? What can I take advantage of? And it sounds like you're off to a great start. So yeah, that's how it goes forever, I think. I don't know if anyone ever reaches a point where they're not checking Stack Overflow anymore. Maybe someone truly great, but I think that would be the exception and not the rule.
Not me.
Yeah, me either.
Can I just ask, what is a Jupyter notebook?
Yeah, I don't know either. I'll be honest.
I'm a
Good
physician. I have
Oh my
absolutely
gosh,
no idea.
it's like the totally trendy new coding thing to do. All the young people are doing it. It's
It changed
very
my life.
exciting
It's
and
so much
new.
better than how we used to have to do it. It's great.
It makes it a
Cool.
lot easier to collaborate on code, I guess, would
Oh,
be
okay.
probably the easiest way to explain it. I don't
So
know.
is
it's like-
is it like a platform or just a method of doing something? Or I guess, what is the term
Yeah, it's like an
referring to?
interface.
Oh,
I
okay.
could, I mean, I
Yeah.
could like screen share this project. I have
Cool.
And you can like, because you can put both code in it and like display like there's different blocks. So like you can put a section of code and then like write a like thing about it, and then you'll see it in the next one. So it's like very helpful for that kind of stuff.
Here's a
Python
Jupyter
is a
notebook.
script, so you either like have to write your code and then run it all and see what comes out, or in this interface you can just give it lines of code and execute them line by line, and so you can really see, like, if I write this line, what does it do? If I write this line, what does it do? And then you can actually, make plots, write yourself notes, all with the code right there.
Yeah.
Nice.
Yeah.
But I
whereas you
actually do
include
not like
markup
Jupyter
and
notebooks, and I do not
tutorials.
use them myself. But I did have to use them a lot in class.
Polarizing topic, who knew?
Very cool.
Yeah,
Huh.
here's my very ugly notebook. Like this matrix is directly latexed into it. It's so long.
That's cool. There's an amazing organization called Women Who Code, and they have got all kinds of activities. I think they start working with like elementary school students, middle school students, like up through college age, and just trying to get more women into coding. Super cool stuff. And I'm not sure if they do anything in an astronomy context, but I guess I wouldn't be surprised if they do. But yeah, they're an international organization now. They do stuff all over the world. The other thing that I thought I'd mention, just for some of our viewers who might not know what a spectra is, what we're talking about here is the light from a star. And you can think of that light getting broken up through a prism. So we can see all the different parts of the light and all the different colors of the rainbow. And with stars, those different colors represent different elements in the star. And so by looking at all those different elements, we can learn a lot about the type of star that we're looking at. And so that's what Ellen was talking about.
Yes. So sorry, I didn't define
Yeah,
that.
it's all good.
That x-axis is your wavelength, so like all the different colors, red, orange, yellow, whatever. And the y-axis is the flux, which is sort of like how bright is it at each wavelength.
Ellen, I was thinking about whether in your future you see any intersection with the work that you did with Southeast Asian studies and astronomy.
Oh, definitely. Yeah, I actually, this was kind of a funny situation. Last summer, I needed one more class for the Southeast Asian Studies major, but the class that I picked was, I think it was only like 4 units, and you need 6 units to have financial aid for the summer. It's silly, but I'm like, I'm poor, I need to take another class. So I think, what's the easiest class I could take? It was an introductory astronomy course with a focus on cultural astronomy. And there was this really cool assignment to write a research paper on how some aspect of your culture connects to astronomy. So I did this whole piece on Filipino mythology across different ethno-linguistic groups that has to do with the origin of the sun and stars and such. So I would love to teach a course like that one that I took.
Very cool. Well, we're about out of time. Ellen, is there anything that you want to leave us with?
think I'm good. I guess I could shameless plug.
Please.
I do have availability in my tutoring schedule right now. So if you go to naturallogtutoring.weebly.com, website.
Well, I'm definitely impressed with your ability to explain scientific information. So I think probably you're an excellent tutor. So take Alan up on that, folks. Anything else from any of the co-stars? All right, Ellen, we've got a thank you gift for you. Mankey will reach out to you and get you all set up with that. Thanks for your time. We really appreciate you being here. That was a lot of fun. Thanks to all the co-stars for being here and all the folks behind the scene, Gavin, our stream master, Maggie, our director of operations, and everybody else at Wyoming Stargazing that helps to make this show possible, including our board of directors. And thanks to all of you at home for watching the Cosmo Show. We wouldn't be here if it not were for all of you. So we really appreciate you being here, and we want to hear from you next time. Call in and let us know what you think about the show and join the conversations. We hope to hear from you next time in a couple weeks. Until then, be well and don't forget to look up. We'll see you next time. See ya.
Bye.